The format of this video will be a bit different compared to the other HTTP response codes. Treating the root codes individually will make everything seem kind of repetitive because the differences between most of the codes in this section is somewhat subtle. The 300 codes are generally designed to inform the browser to go to a different URL automatically, with the user only really noticing that the URL possibly changed. There are two dimensions for the redirection codes that we need to talk about: the type of the method that's used when the redirection occurs, and the duration of how permanent the change happens to be. To start, let's try submitting a form using my manual web client to see what we get back. We have here a simple form for ordering a coffee that is processed using a post method. Sending in the name of the coffee to be ordered comes back with a 303 see other response. The browser is supposed to then go off to the location header using a get operation. Looking at the same operation in the inspect window for Firefox shows the redirect to the /barista route using the get method. Let's look again at the same form, but this time the application is going to send back a 302 found message. The browser still behaves the same way, loading the barista route. At this point, it looks like we have found two codes that seem to do exactly the same thing. While the 303 indicates that the browser must use the get method, the 302 actually indicates that the browser may use a get if it wants, or it can use a post, or it can use whatever else it wants. However, most browsers actually do use a get when receiving a 302 response, and most applications would use 302 as part of a post redirect get, or PRG, form processing event, even though a 303 would be more appropriate. A response code of 301 also produces the same behavior where the redirect is done as a get. Let's try the form again with a modification made to the server so that it returns a 307 instead. We can see in the network tab that the original post operation returned a 307, and then the browser went to the /barista URL but using a post. Yes, the data from the form would have been sent in as well on the second post. The operation failed, of course, because my application was expecting only a get on the /barista route. The 307 response is an indication to the browser that it must preserve the same method when visiting a new location. This type of redirect could be useful in an application where you need to inform the posting software that it now needs to post to a new route. The 308 response code causes the browser again to behave exactly the same way as the 307 response, where the post is preserved. Let's put all of this into a small table so we can keep things straight about what's going on. The 303 always follows the redirect with a get. The 302 found could be any method, but most browsers will use a get. The 301 move permanently is the same as the 302. The 307 temporary redirect will be the same method as the initial request, and so will the 308 permanent redirect. You'll notice the word temporary and permanent appear in some of the redirect names. The 302 is actually a temporary redirect as well, it just happens to use just the word found. We'll consider a typical search engine crawler such as Bing or Google. Basically, a crawler visits a web server and scrapes the content by following all the links and builds a database for other people to search. If we iterate the three entries in the table here, we will see that the first request results in a 200 OK, but the title changed, so the crawler would update the database to reflect the new content. The request for the menu results in a 302, which means that the crawler must also fetch the new location. However, since 302 indicates a temporary location, the crawler does nothing except possibly update the title and other content. The request for the images generates a 301 response. Since a 301 indicates a permanent redirection, the crawler should update the URL in its database to reflect the new location. In reality, of course, crawlers would not update quite this quickly. They would probably make note of the change and update only after several visits, seeing that everything is stable. Going back to our table, we'll now add a second column to let us know about how long the changes are going to be good for. This now leaves us with two more codes that we haven't looked at yet, the 300 and 304. The 300 multiple choice is the only 300 code that doesn't cause the browser to automatically load a new resource. It is used by the server when a client requests something, and the server has multiple versions of the items that could be returned, such as in different languages or maybe different resolutions for a photo. Ultimately, it is the user who will make the choice and pick one. For this demonstration, I configured Apache to return a 300 code providing two links to a set of instructions, one in English and the other in Arabic. When we visit the server trying to read the instructions route, we are presented with an HTML page with both options. The 300 response is providing some semantics to the HTTP protocol, but really from a user's point of view, a simple web page with the options would have been fine. The 304 not modified response is actually a direction to the browser to load the data from the browser's cache because nothing has been modified on the server. Let's load the index.html file from the server with the cache disabled. We see that the request comes back as a 200 with a value in the E tag and the last modified date. Make note of the value here. If I now enable the cache and refresh the page, you'll see that the server responded with a 304 to indicate that the browser already has the item. The server knows the browser has the correct version of the file because the request included an if modified sense and an if none match header. Redirects are quite common to send users from the non-secure HTTP version of a website to the secure HTTPS version. Let's take a look at what happens if we ask to visit http://mozilla.com. We see the first redirect to the HTTPS version, and then for some reason they picked 302. Then we see the browser attempting to read the HTTPS page only to get a redirect to a folder called Firefox. When attempting to read the Firefox URL, we get another redirect to www.firefox.com. And finally, the firefox.com URL responded with another redirect to a subfolder for English US.